All right, we are in section 5.2. This is the top of page 233. We're going to talk about angle, side, angle, triangle congruence. So in the last section, we talked about two figures are only congruent if, or two triangles are only congruent if all three angles in each triangle are exactly the same and all three pairs of sides are exactly the same as well. From this point forward, we can use these triangle congruence theorems that are basically shortcuts to determine whether two triangles are congruent. And this first one is called the angle, side, angle, triangle congruence theorem, or ASA is how I'll shorten it. And basically this says if you have two congruent angles in both triangles and the included side is also congruent, then that's enough information to deduce that everything else within these two triangles is also congruent. It'd be like if there were two different cell phones sitting on a desk and I only told you the exact length and width dimensions of those two cell phones. Well, if you were an expert in cell phones, that might be enough for you to say, oh, these are the exact same cell phone, the exact same brand, even though I didn't give you all of the information about the cell phone. And that's kind of what we're doing with these triangle congruence theorems, which are going to really dominate this your entire time in geometry in July. So the angle, side, angle, triangle congruence theorem, two congruent angles, and the included side has to be the same. So just to make sure we understand what included side means, every angle is made up of two line segments. So if you have two congruent angles or two pairs of congruent angles, each one of those angles is made up of two line segments. The line segment that those two angles have in common is the included side. Sometimes people say it's the side that's in between the two angles. That's helpful for some people, but can also kind of get a little confusing as well. So let's look at the example one at the top of this page. We're going to determine whether the triangles are congruent, and right now we're only going to use the angle, side, angle, triangle congruence theorem, because as of this moment, you don't know any of the other theorems. So we have two triangles. We have triangle ABC. Angle A is 45 degrees. Angle C is 61. And segment AC, or side AC, is 2.3 centimeters. The right triangle is triangle DEF. Angle E is 74 degrees. Angle F is 61 degrees. And side DF is 2.3 centimeters long. So step one in this problem says find the measure of angle. And of course, all the steps in this first example are outlined for you. We've talked about this sum, the triangle sum theorem. There's 180 degrees inside the triangle. So if we know angle E is 74 and angle F is 61, we add those together and get 135. So that means we know that angle D is whatever's left over to add to that 135 to get to 180. We subtract 135 from both sides. The measure of angle D is 45. And of course, the whole reason for doing this is now we have two congruent angles amongst these two triangles. That's step two in this problem. It says compare the angle measures and side lengths. We see that the measure of angle A is equal to the measure of angle D. They're both 45 degrees. We also see the measure of angle C and the measure of angle F are both 61 degrees. Now the key part is for angle, side, angle to work is the side in question has to be the included side. AC and DF are both the included side, because if you look at this problem clearly, you can see that those two segments help form the 45-degree angle and the 61-degree angle. And also you can kind of see how that side is in between those two angle measures. So that is the included side in this. So that means these two triangles are congruent by the angle, side angle, triangle congruence theorem. Let's walk through the example 1b problem together. We have triangle JLK at the top. Its angle J is 31, angle L is 110, and segment JL is 62 inches. The bottom triangle is triangle NPM. Angle N is 38 degrees, angle M is 31 degrees, and side PM is 62. So again, the first thing I see is we do not have two congruent angles, so we need to do the triangle congruence theorem, and we need to find the measure of angle P. And that's what step 1 says to do. Find the measure of angle P. I'm going to pause for a minute and let you go ahead and find the measure of angle P. So you should have gotten 111 for the measure of angle P. And at this point, we can compare the angle measures and the side lengths. And we can either answer this on our own, or we can kind of follow the prompt on step 2. But ultimately, we see that angle J is congruent to angle M. The measures of those angles are equal. We see that segment JL is 62 and segment PM is 62. So we have an angle and we have a side. But for angle, side, angle to work in this problem, we'd also have to know the measure of angle L is equal to the measure of angle P, because that's the other angle for angle, side, angle in this problem. And they're not, obviously not equal. One's 110 and one is 111. So these triangles are not congruent. Triangle MNP is not congruent to triangle JKL. All right. On the next page, the top of page 234, go ahead and pause the video and try the your turns. Determine whether the triangles are congruent. And ultimately, we're trying to do this by angle, side, angle. So I'm giving you a little bit of time to try number 5. We see in the problem the measure of angle P and the measure of angle C are equal. Those two angles are congruent. We also see the single hash mark on the segments. Segment BD is congruent to segment DC. Those distances are equal, which means we need another missing angle, and we actually have that even though it's not marked. Angle ADC, the measure of angle ADC is 90, because it's marked by that perpendicular box symbol. And we also know that the measure of angle ADB, which is the left triangle in this diagram, has to be 90 as well, because those two angles are a linear pair because they form a straight angle. And a straight angle is 180 degrees. So that means they're both 90 degrees, which means the measure of angle ADB is equal to the measure of angle ADC. So those triangles are congruent by angle, side, angle. If you haven't already tried number 6, go and try number 6. All right, so giving you some time to try that one. Again, I'm going to look for my congruent angles first. The left triangle, angle Q, has a 38-degree angle. The right triangle, angle T, also has a 38-degree angle. I see a congruent side. Segment QR on the left is congruent to segment TU on the right. Now what we need to do is angle R and angle U have to be congruent for angle, side angle to work. Angle P and S don't really matter because we're trying to prove angle, side, angle. So you need to find the measure of angle R using the fact that there's 180 degrees inside a triangle. If I've done my math right, the measure of angle R, I believe, should be 70 degrees, which means angle R and angle U, those measures are not equal, which means the angles are not congruent. So the triangles, we'll just say, are not congruent.